Hello, my name is Esperanza, and I'm going to share with you some of the work we have been doing recently with Drs. Quiroga and Maletto in collaboration with Dr. Huberman. The goal of our work is to develop a vaccine against Avibacterium paragallinarum. To this end, we identified a set of candidate antigens through a reverse vaccinology approach. Avibacterium is the causative agent of infectious coryza, a disease that affects the upper respiratory system of chickens. It is classified into 3 page serogroups, A, B, and C, and is widely distributed in poultry production systems all over the world, causing significant economic losses due to diminished growth performance and egg production. Although vaccination is the main form of prevention, available commercial vaccines based on inactivated international reference strains show insufficient protection against local strains. In hopes of developing a new vaccine that overcomes this problem, we aim to identify in silico antigens with broad protection potential using comparative and subtractive genomics and sequence analysis. Our goal was to identify the most conserved, essential, most antigenic, accessible, and non-host homologues proteins from the 3 page serogroups of Avibacterium. First, by comparing the proteomes of the chicken and 3 serogroups of Avibacterium through protein blast, proteins with high similarity with the host were identified and discarded from the dataset. Next, a comparison with the database of essential genes was performed, again, using Protein Blast. The Cello and PSORT-B servers were then used to predict subcellular localization. If both servers agreed on the possible location, proteins were classified into cytoplasmic, inner membrane, periplasmic, and outer membrane. Proteins for which there was no consensus among the servers were grouped into a 5th group. All proteins identified as outer membrane by at least one server were selected for further studies. After that, we assessed the conservation between the most antigenic protein sequences with a multiple alignment performed with MAFT and a phylogenetic tree built with FAST-tree. These are the completely identical essential outer membrane proteins shared between the 3 serogroups. We selected 5 proteins families to proceed with more analysis. We characterized the 5 best candidates using EMBOS to estimate molecular weight and isoelectric point, TM-HMM to predict transmembrane alpha helices, PRID-TM-BB2 to identify transmembrane beta sheet and beta barrel topology, and signal P to predict signal peptides. According to PRID-TM-BB2, these proteins have no beta barrel transmembrane structures. In addition, most of the best candidates have lipoprotein, signal peptides, and no transmembrane alpha helices. To sum up, in this work, we use sequence analysis in conjunction with comparative and subtractive genomics to select the proteins deemed the most antigenic, essential, conserved, accessible, and non-host homologues. Among the predicted antigens, these 5 proteins were identified as potential candidates qualifying all the set criteria. Although only a few strains were analyzed and in vitro and in vivo testings are still needed to validate the protective effect of the newly identified antigens, this study provides a basis for the development of a novel subunit vaccine against Avibacterium. Thank you for the attention. For any questions, please feel free to contact us through email. Cheers!